Thank you very much, and welcome back again to this one aristocratic channel of ours. Please make yourself a favor, listen to this concept up until to the end of this module, because of this is a very important note that you need to consider if you want to do well in your examination that you are going to write now in term 4. Make sure that you are using that in term 2 with the geomorphology. Then this is the study of rock, and then this is the revision for exam purposes. All right, without wasting any time, the show rocking, remember to hit the subscription button and to invite others to subscribe. Appreciate that. And then let us understand that we are here is that in the examination, the structures of the earth would be drawn. You as a person, so we are saying that you need to lay. We are saying that the molten mineral will remain half, and then you get a true picture that you can be given in the examination. Okay, right of the earth, we are having the crust, which is we are having the inner core. Number 2, the inner core, it is at the outer, the epicenter. You've got the outer core, the mantle now. And so under this, you can see the crust is the outside layer. The mantle is the following now a layer in this regards, and then we've got the outer part that it is a yellowish inner core. So that is how you can be able to label it, and it can be for a maximum. Let us see the overview. Remember that we said that we are having internal structure. So we want to know now, and they are characteristic when, how do they look? And we are saying crust, it is 262. We are having the mantle, which is at 2,900 kilometer. Why we are saying that from this, from the distance of here up until to this reference point, it can be that distance. And then we've got the outer, which is 2,250. And then this is the outer core, and then the inner core, it is 1,200. So you are having that the characteristics of the crust. This is a solid rock. The mantle is the molten rock. The outer core, it is the dense but liquid, and the inner core, it is a solid without failure. And then if ever we are moving on again, we must understand that we talk about the crust can be divided into 2 types. And then number 1, I've stipulated the continental crust, which is a seal, or number 2, the oceanic crust, which is the simmer. It is thinner and it is denser. So we are saying that here the continental crust, and it is mainly granite. And then the ocean crust, it lies under the ocean, not the continent, and the continent crust. So it lies on 2 aspects. And then it is mainly a basalt and a gabbro. So this is the basic picture now of this crust. So this one, it is the continental crust is thicker than the ocean crust. So where is the ocean crust? You can see that this greenish part overview the circumference, that it can be the oceanic crust. So we can see that denser, it is much lesser compared to the continental. So the continental, you can see how dense, how big that the continental crust is thicker than the oceanic crust, because of they play both a major role. Right? And then if ever this key concept where we are talking about the classification of rocks, how can we classify rocks? Remember the weight classification, we are saying maybe you are in 10A, 11, 10B, 10C, 10D. So those are the classification. You are together, but you are in different classes doing the same grade. So that is how we can simplify that. So we are saying the rocks of the earth come to different sizes. So they differ in sizes, they differ in color, and they differ in shape. How can we see that? The granite and the shale, they are different. The colongite and the obsidian, it is different. So we are saying that the rocks can be classified into 3 main types of rocks. So you need to remember I've highlighted it, and I've also written those. So typical question, name 3 main types of rocks. It can say that. So how can you name them? This is how I've made it simple. Number 1, we've got the types of rock, which is then igneous rock. Number 2, the sedimentary rock. Number 3, the metamorphic rock. So how are they formed? Igneous, and it cools and crystallizes. Number 2, the sedimentary, it is deposited by the wind and water, and ice build up in layers. So we'll further see that igneous and sedimentary rocks, they changed by heat and the pressure, which they receive now from this crust, which it is very hot underground. So these are the examples now of igneous rocks. So the typical question number 2, they can say, give example, obsidian, basalt. Example for the sedimentary, it is number 1, the conglomerate, limestone, and the shale. The metamorphic rock, it is the gneiss, it is a marble, and it is a slate. Those are the example. You need to know them by heart. If we are moving on again, we must understand that we move to 1.3, whereby we are talking about the intrusive igneous activity. So we are saying this is activity which occur when the enormous mass of magma does not reach the surface and solidifies, it hardens. So to solidify, it hardens. So the figure here, it shows the intrusion form. All right. So what we can see here, it is that underground here, it is very hot. Where the lupus and the batholith come from, it is very hot, and it is a bit cooler above in the laccolith. In the laccolith, it is much cooler. So we are saying it pushes the overlying strata upwards. So this is the picture. And then the largest of the intrusive form, and it is usually made out of granite. You can see the density here. You need to identify these labelings. And then you need to know also their function. And then you can also identify the lopility. So we are saying that the magma here into just between the sedimentary layers. The layers underneath cannot support the weight and the skin down. The saucer-shaped intrusion, it is formed at that part. So you need of 9 marks. All right. And then if ever we are moving on again, so we are going to talk about the changes in the position of continents over time, which is regarded as the drifting of continents. So we would want to find why is it possible that this can take place. So let us look at an overview of the Alfred Winger. He was saying that some of the forces in Africa and South America and Europe, how is that possible? The word look like is disjointed together. So we are saying that happens based on the changing of position of continents over time. All right, so that is the continental drift. So the continental drift. So what is the continental drift? You can see here, it is the movement of the continents, and they move away from one another. So you can see that over 200 millions of years ago, the movement of the Earth, you can see, and then it went to 1,335 million of years ago. You can see the basic of the structure. So it shows that the drifting has taken place, and the present day, you can see that the Earth has changed, and then we are saying that is continental tectonic plates, and they drift further away. So the continents, they become disjointed. So these are the continents that we are talking about. They become disjointed because of the Earth, it moves. So we've got to understand that is called the continental drifting. It is the movement of the continents over time. So we'll know later what causes continental drifts. All right, that is why you need also to tune on up until to the end of this chapter. And then if ever we are moving on, we've got to understand the key concept based on the time. So we are saying that there must be a form of evidence in terms of the movement that are carried away over time by this. And then in this instance, we are saying that number one, we are saying we've got the continents fit perfectly. So once upon a time, you would see that there was a jointed continents between the greenish and the bluish part. They were jointed perfectly. We are saying the east coast of the South America and the west coast of the Africa match almost perfectly the same. And then number two, we are having now the Glenser deposit match. So the Glenser deposit match, you can see that there was a movement over time based on these tectonic plates which are taking place. And then we are saying the ice sheet over the continents 3,000 millions of years ago, the glacier deposit the match. Okay. And then we've got to understand that we talk about number 3. We say that the rocks formation, the match. So you can see that as the time goes, there is a what? There is a movement of what? Of these continents being disjointed or being scattered up. So we are saying that some mountains end close to the east coast, rocks at the same type and about the same age. And then we've got to understand when we're talking about number 4, the fossil remains of the Laisterasas have been found in Africa, India, Atlantia, and then could not swim. So this is based on the what? On the movement. And we've got to understand now this concept that I was introducing because of the go hand in hand, the tectonic plates. One of the key concepts that you must understand, it is to define the concept. What is the plate tectonics? So we are saying that this is the theory that explains the movement of continents. It's called the plate tectonics. That is for 2 marks. How do they move? So you can see that number 1, the plates move away from each other. There is a divergence that is happening because of they move away from each other. And the arrows, they are showing that to say they move to the opposite direction. So we are saying number 2, these plates can move towards each other. So that is convergent. And then the plates can pass each other as based on the arrows that we are given. And then we are saying they pass each other. So that is how they move. All right. And then here you can see that plates and types of plates boundaries. So you can see that we have highlighted in the reddish, you can see that there's a tectonic continents, they are moving on each other. So it represents that. So you can see basically also on the arrows there. So these arrows, they are coming to join together, but this one is going this direction with this one going up direction. So those are the arrows that we are talking. See them based on the arrows that have been as now stipulated. All right. And then we've got to understand that there are 4 types of plates boundaries. Number 1, we are having the conservative, which is the transform boundary. So you can see that as these continents come together, they move out of each other's way, separate, and they pass each other. Number 2, we've got the come to join together. They are coming and they join to the opposite direction. And then we are having the constructive divergent boundaries. So they go in number 4, the destructive or the subduction boundary, whereby there is a presence of the slope and they are moving in the city of the slope, they will never meet. All right. So you need to identify these figures in the examination. All right. And then if ever we are moving on again, let us understand that we've got one of the key concepts which we are talking about, the faulting and folding and faulting. So we need to understand what is folding. So you've been folding. Sometimes you're close at home. So you must understand in this concept in geography, when we're talking about now the folding, what is it? So you can see that when 2 compressed forces come together, like let us assume that in this figure, there is a car coming in this way and there's a car coming this way. In this point, they will collide together, causing a friction. So that will be folding. So what is going to happen is that, number 1, the forces, they push the rock layers together. So from this direction and this direction, they will meet somewhere in the middle. And this would create the inclined downward bend. So this will bend. And as they bend, you would see that there would be, which the movement, it would be up and down and on the sideways. So that is what we call the rocks bend into folding. So they fold as this process is happening or is taking place. And then here you can see this is the picture that we are talking about, which is called the folding. So there's a pressure that is coming from the opposite direction, causing them to fold. Now we move to faulting. So we are saying that a faulting is a fracture or the crack between 2 blocks of rocks faults allow the blocks to move relatively to each other. There are three types of faults. So we need to understand that in the examination, you need to give the concept now of the what is for 2 marks, and you need now to list the three types of faults, which is number 1, we've got the normal fault. Number 2, we've got the reverse fault. Number 3, we've got the strike slip fault. So we are saying under this, you can say the normal fault, it is the tension between the forces. So as you can see that here, there's there's a slope that is high and the slope that is less because of the tension, it moves in opposite direction. So that is why we conclude to say that there is one block slide downward. That is the figure there. Then we are having what is happening now, and the slope would move in the opposite direction, creating the pressure at the back. Now the force is upwards. So this is the picture, one block slide. It is upward, there it was downward. So that is there called the reserve force. And then we are having the strike slip fault, which is called the lateral force. So what is happening is that these blocks, they are at the equal density, at the equal altitude ways they move on the lateral ways, creating the what? The one block slide pass another. So they pass one another because of they are moving in the opposite direction. That is very important. You need to know it. Right. And then if ever we are moving on again, where we need to earthquake. So we can be asked the in the examination the definition and the earthquake. So we are saying that in 4.1, important things that you need to know about the earthquake. I've also dangerous earthquake can be. So here we need to know that it destroys everything, lives, buildings. So we are saying we need to know how the earthquake is measured. Living with earthquakes, how can we do? Where are earthquakes found? What is an earthquake and what causes the earthquake is some of the things that we are going. So you can see what is an earthquake and what causes an earthquake. So can you see here, based on these slides, there is a up and downward movement of the buildings which is taking place, and it is created by the earth surface in the magma. So we are saying that an earthquake is a violent shaking made out of the giant, slowly moving tectonic plates, suddenly moving where these plates meet, which causes. So the cause of the earthquake is when these plates meet, then they will cause collision and they will cause earthquake and there will be eruption. You need to understand that concept. And again, we need to understand this particular concept, whereby we are talking about the earthquake concept. Here we need to understand that when this earthquake it is happening, what is going to happen? There will be a crack at the epicenter of the earth, and we are saying here we've got the focus of the earth, and then we are having the seismic waves and the fault. So those are the concepts that we need to understand, but we are discussing them now. So what are these? These are the break in the earth outer layer where the tectonic plates meet. So that is the fault. The tectonic plates, they will meet here, and the fault will be here before the eruption can take place. Then we've got the focus. That is the point underground where the earthquake starts. So the earthquake, it will start here, and it will erupt there at the focus. So if ever we are moving, we are having the epicenter. So we are saying this is the point on Earth's surface directly above the focus. So it is above the focus. It is called the epicenter. There is it. And then we've got the seismic waves. These are invisible waves of energy released by the Earth. They are released by the earthquake. Then we've got the seismograph. We are saying is an instrument that is measured and records the earthquake. And then we've got the Richter scale, the Richter scale on which the intensity of the earthquakes is measured. So we have answered those questions there that we were asking ourselves previously. And then here we need to understand how do earthquake affect people. Number 1, I've written there fires, electricity, and gas, they can be broken. Number 2, broken fuel starts the fire in the fuel station. Number 3, specially designed buildings are damaged but do not collapse. Number 4, people are injured or killed. And the other one, the bricks and tiles are designed to crash on the streets. The other one, there's a collapsed sideways and cut off town. There's a broken water mains. and we are having the cracked walls make up building unsafe. So that is the effect now of the earthquake. All right. And then when we are moving on again, we need to understand this concept very well. The tsunami, the effect of tsunami. And then we need to understand now what is happening with the tsunami. So number one, they will say explain the development of the tsunami, perhaps in 10 marks. You need to understand that number one, the tectonic plates of the earth surface slip. They release a massive amount of energy into the of energy underground into the water. So what is happening? Number two, the energy started to travel up to the surface, normal sea level. And number three, the energy ripples outwards horizontally. What the arrows? There's a movement of the sideways. And then when it moves to the sideways, waves, they slow down and become higher. And they will meet with the dust particles. And then number five, the coastal region will be destroyed. That is 10 marks. So one of the key questions that can be asked in the examination, what can be done to reduce the impact of the earthquakes? What can be done to reduce the impact of the earthquakes? So we need to know that aspect. Number one, what is it that we can do? There is listed, and I have written to watch here the sea if the water pulls back, which is the tsunami. Number two, to locate active fault zones. Number three, identify high risk areas where the tsunami can occur. Number four, prediction where it might occur, the place where it might occur. Number five, emergency services must be taken immediately. There must be an action. And number six, there must be dams which must be built to absorb the shocks. The other one, strengthen the roads, houses, and bridges. They need to be maintained properly. And number eight, the earthquake resistance to building. So those buildings, they must be built when they are resistant to earthquake. And then lastly, there should be a strong breakwaters to protect from tsunamis. That is for 10 marks. Okay. We must understand this key concept whereby we talk about the volcanoes now. So we need to understand the structure of the volcano. We need to identify, and we need also to give an explanations to this. So this is the volcano. So can you see that there's the magma chamber, which is very hot here, basically at the epicenter underground of the Earth's surface. So what is happening? The magma chamber would release heat, and this heat will be catched or will be caught by number two here, which is the fissures of the Earth. And these fissures of the Earth would travel through the pipe channel. And this is the pipe channel. Number three, the pipe channel. So when we are having the pipe channel here, this heat will travel and it would create a lava, and the lava would explode. So remember that on the sideways, we are having the volcanic cone. You need to see it. There's a lava flow again, which is happening because of the movement of this. And then remember, there's a crater. After now, the lava, it would bomb and gases would be released. That is the material ejection by the volcano. You need to identify this figure. And then here we are having the three stages of volcanoes that are still happening. So these are volcanoes that they still erupt. They are still active. They are more dangerous. Number two, we are having the dominant volcanoes. They show no signs of active, but they are likely to. These volcanoes that will never erupt again. That is for 6 marks. And then if ever we are moving on again, we are seeing that we've got one of the key concepts that we still need to discuss pertaining to this. So let's 3 types of volcanoes and explain them. We've got the cylinder cone. That is the type of the volcano. It happens now in cylinder. So there's a movement of these tectonic plates moving in the same direction. They would erupt here. So we are saying the ash and solid materials are ejected. The volcanic material solidifies and lands around the crater. There is the smallest cone, and at the steepest slope, as you can see, the slope is steep. An example, it is the Monte Nuononie Temple in Italy that it has happened there. And then we are having what we call And number 2 there, we are having the shield volcano. And then we are saying there's a lava. The lava is a gaseous and rainy. There are few explosions. The slopes are very gradual. Example is Mauna Loa, and it has happened in Hawaii. And then we've got the composite stratovolcano. Number 1 is an alternate layers of the eruptions are often explosive. Examples are Vesuvius in Italy, and they've happened in Japan. So you need to know them. You need to identify each of them. All right. And then we are moving to 5.4, when we are talking about how the volcano affects people. So we have discussed that. Number 1, we are saying the dust can block the sun's heat and increase rainfall. Number 2, there can be showers of ash and the lavas. Number 3, the lava burns the tree and vegetations of the houses because of the what? Because of the densities of the heat. What is happening? People can suffer the health problems because of the realization of the carbon dioxide that is taking place during this process. And then let us understand to collapse, and there will be a shortage of houses. Water supply is polluted, and then the hot springs, and then we must understand hot underground water that is used to generate electricity will also be a problem, and hampered because of the this contamination of these gases that are released by the mud flows. So let us understand that the volcanic ashes, they act as the fertilizers, and then the river system, it is unchanged. The diamonds in the volcanic pipelines, they still occur. And lastly, volcanoes are tourist attraction. That can be for 12 months. Hitting the subscription button, ensure that you are sharing to those who are concerned. MATRIC+NATED specialist. Thank you very much for your time. See you.